Welcome back to Elimination Method. Today we're going to talk about when we can use elimination method using multiplication. Notice, this is when we do not have identical or opposite terms. Just a review, when you have identical terms, meaning either your x's are exactly the same or your y's are exactly the same, you're going to subtract. Remember, when you have opposite terms, such as negative 5y and positive 5y, or 10x and negative 10x, which are opposites, you would then add. What do you do when you don't have either one? Well, this is where multiplication will come into play. So let's take a look at an example. X plus 3y equals 6, and 2x minus 7y equals negative 1. You can see from this first example that we do not have opposite or identical x's. We do not have opposite or identical y's. So this is where we're going to use multiplication to create either identical or opposite terms. I like to use addition, so I'm going to create an opposite from this first equation. We have 2x for the second equation. I want to create the opposite of that, which would be negative 2x. So I'm going to multiply the whole first equation by negative 2. And that's going to give you negative 2x minus 6y equals negative 12. Your second equation will stay the same. Notice now that I've done that first step, you have opposite x terms. Once you have opposite or identical terms, you can proceed with the method we talked about today. I am going to add these two equations together because the x's are opposites. Negative 2x plus 2x would cancel out. Negative 6y plus negative 7y gives you negative 13y. And negative 12 plus negative 1 gives you negative 13. You will then divide both sides by the coefficient, which will then give you y equals 1. Like we did yesterday, you are going to then take 1 and plug it back into one of your original equations for the variable. Since I have the value of y, I'm going to plug in 1 for y. It does not matter which equation you plug back into. I'm going to choose to plug back into this first equation, which would look like this. X plus 3 times 1 equals 6, which means x plus 3 equals 6. Subtract 3 from both sides, and you get x equals 3. Now that you have a value for x and you have a value for y, you can write your solution as 3, 1. What I want you to notice is that the only new step is this very first part right here. I had to use multiplication to create opposite terms. Once I had those opposite terms, I was back to where I was yesterday with being able to add my equations and then solve. Let's take a look at another example. Next example is 9x plus 3y equals 12, and 2x plus y equals 5. If you wanted to create opposite x's, you could. You could use 2 to multiply the first equation to give you 18x, and you could multiply by negative 9 on the bottom equation to give you positive 18x. There's a slightly easier way to do this. I notice that y right here is really 1y, and I know that if I multiply y by negative 3, it will give me the opposite of 3y. So that's exactly what I'm going to do. I'm going to multiply this bottom equation by negative 3. I'm doing that because then when I multiply, you will see that I will have opposite y terms, which can then be eliminated. So your first equation will stay the same. 9x plus 3y equals 12. Your second equation becomes negative 6x, minus 3y equals negative 15. Your x's are not the same or opposite, but that's okay. Your y's are. Since your y's are opposite terms, you are going to add. We have 9 plus negative 6, which is 3, so 3x. We have 3y plus negative 3y, which will cancel out. And we have 12 plus negative 15, which is negative 3. Divide both sides by 3, and we come up with x equals negative 1. Now that you have the value for x, you can then take that value and plug it back into one of your original equations. I'm going to choose to plug in negative 1 into this second equation. So that will look like this. 2 times negative 1 plus y equals 5. That means that negative 2 plus y equals 5. Add 2 to both sides, and you get y equals 7. Now that you have a value for x and you have a value for y, you can write your solution as an ordered pair. Negative 1, 7. Here's another example for you. X plus y equals negative 3. 5x minus 2y equals negative 50. For this example, there's a couple different ways you could do it. You could create opposite or identical x's, meaning you could change this x up on top into either 5x or negative 5x, which would then allow you to eliminate your x's. Or you could create 2y out of the top y value by multiplying the whole equation by 2. You could also multiply the top equation by negative 2 and create identical y's. You have options in how you want to solve this. But again, I'm going to always suggest that you use addition. And in order to use addition, you're going to need opposite terms. I'm going to choose to make my x's into opposites for this example. So I'm going to multiply this top equation by negative 5. When I do that, I get negative 5x minus 5y equals 15. Your second equation will stay the same. Now take a look at what you have. Your x's in this case are opposites. And like you've heard me say, when you have opposite terms, you are going to add them together in order to eliminate. So negative 5x plus 5x will cancel out. Negative 5y plus negative 2y is negative 7y. And then 15 plus negative 50 is negative 35. Divide both sides by negative 7, and you come up with y equals positive 5. You will then take positive 5 and plug back into one of your original equations. Looking at my original equations, it looks like it would be easier to plug into this top equation. That will look like this. X plus 5 equals negative 3. Subtract 5 on both sides. You will come up with x equals negative 8. As you can see, I have a value for x and I have a value for y. I can now write my solution as an ordered pair. Negative 8 is my x and 5 is my y. So my point of intersection, if I was to graph these, or your solution as we call it, would be negative 8, 5. Let's take a look at this next example. 3x minus 3y equals negative 3. 2x minus y equals negative 5. For this one, I'm going to demonstrate how to create opposite terms for your x's. Remember, it's not the only way to solve this equation. However, I want you to have an example of where I multiply both the top and the bottom equation in order to create opposite terms. Since I know that 2 does not go into 3, I'm going to multiply 2 times 3 and use the number 6 as my goal. If I want to create 6x and negative 6x, I'm going to use multiplication on both the top and the bottom. Look at what I'm going to get. Negative 2 times 3x will give you negative 6x. And then 3 times 2x will give me positive 6x. Notice these are opposites of each other, and you know that when you have opposites, you can add. Let me finish the distribution of the negative 2 and the 3. Alright, now that I've distributed both the negative 2 into the first equation and 3 into the second equation, I have 2 new equations. Notice your x terms are opposites, so you're going to add together in order to eliminate. 6y plus negative 3y is 3y, and 6 plus negative 15 is negative 9. Divide both sides by 3 to give you a y value of negative 3. Then take negative 3 and plug back into one of your original equations. I'm going to choose to plug into the bottom, which would be 2x minus negative 3 equals negative 5. Notice you are subtracting a negative, which means you're really adding a positive. I will now go ahead and solve this equation. Subtract 3 on both sides, which will give you 2x equals negative 8. Divide by 2 on both sides, and you get x equals negative 4. Your x value is negative 4, and your y value is negative 3. Let's go ahead and wrap up these examples by putting some thoughts together. When your equations do not have identical or opposite terms, you can use multiplication to create either identical or opposite terms. In the examples that I've done, I always will suggest that you try to create opposite terms so then you can add. The reason why I make that suggestion is because you are far less likely to make an integer rule mistake that often occurs when you use subtraction. Can you create opposite terms? Sure. Can you create identical terms? Of course. It's your choice how you would like to set these up. Keep in mind, you are using multiplication to help you create opposite or identical terms.